your destination for first content, updates, and gaming.
Welcome to the fun.
First Updates Now is supported by Kettering University. Discover why Kettering University is the #1 choice for many first students and schedule your tour at kettering.edu. And by Stryker Careers. Help create the next medical breakthrough in a fantastic internship or career when you visit careers.stryker.com. Our final team of this evening is going to be team number 95, the Grasshoppers. This team has been doing a fantastic job with their build blogs in every year that I've seen them so far, coming in from the New England district as well, too. And we have James from 95. Do you mind introducing yourself a little bit, James?
Hi, I'm James Cole Henry. I'm the head coach at 95. I was actually a student from 2001 through 2005, and I've been the head technical coach since 2010.
And great to get different perspectives from mentors and students being on this as well, too. So we're excited to speak with you about 95. You've already put out some cool media and stuff, so we'll be referencing that. But why don't you take us from the top, James, and what 95's been up to?
Off to a slow start. Build season comes right around the finals for our home school. They run on a semester system, so we're light on students at the moment, but it'll pick up. It always does. Initially, we've been doing design function, or really function prioritization, with the idea of building a plan that the robot and the team can grow into through the season. We don't want to aim to build the highest functioning robot possible. Or let me take a big step back. Week 1 robots often look very, very different from week 6 and 7 and Worlds robots. So pacing your build so that you get all the right fundamentals dialed in for week 1 is a really important process for us. It's something we've been leaning into the last couple of years, and it's paid off for us in terms of meeting our goals, having everything sorted, and then learning from week 1 and adding the improvements that we need after that.
Yep. How does the changeover with no bag affect that strategy of kind of evolution of your robot over the season?
It makes it possible for us, frankly. We're a small team. We actually have the most mentors we've ever had, with 6 or 7, and about 15 students. So we've built one practice robot ever. So pre-bag, or in the bag era, in the shipping era, making these improvements, they were small steps in between each event, but without the bag, we've been able to make really big improvements between events so far. And that's worked well for us.
So 95 has published a lot of material so far, and want to hop into your build thread that you have on that. So Can you talk to us a little about some of the process from kickoff up until now, what you've been working on?
Yep. There's a lot. Let me think about that for a second.
Yeah.
Like most teams, we read through the manual. We figure out all the actions that we think a robot can take, all the functions that the machine might need to play the game. And then we use a weighted decision matrix to determine the archetype that we choose to play after brainstorming a bunch of different archetypes. I think we came up with 4 or 5 this year. And then we do this actually explicit layout of phases in our build is new for us this year. And to put our choices in context, we also do the same exercise for what we think a second pick, a mid-tier robot, and an elite robot will all have. And then we aim to put ours between the mid-tier and an elite robot, because we certainly we simply don't have the bandwidth to build an elite robot. But we have enough experience among our mentors and a lot of good resources for our students and outside support that we can do, I'd say, a 75th percentile sort of robot. We're usually in the hunt for being a captain or a first round pick at most of our events. So we try to aim for that.
So what's your overall breakdown thinking right this second? So are you a high goal shooter? What are you doing for climbing? Like give me the mental image of like where you want to be for week 1 right now.
For week 1, 1 to 2 cargo and auto in the high goal. We're going to do our best to be a super fast cycler. We enjoy making robots that do that. Again, shooting in the high goal from a not a good term for it this year, a fender shot, for lack of a better term, where we just smash into the side of the hub and shoot fixed. That worked really well for us in 2020 and in other years when that's been an option. Other than that, we're banking on a 6-point climb, maybe a 10-point climb, but probably not for week 1. We think doing the 6-point climb is a relatively simple mechanism. We can basically copy it from our 2020 robot. But the add-on of grabbing the 10-point bar is something new, and that will require development and time. And I'm not sure that that mechanism would be ready for week 1. We'd rather have more drive practice than have that dialed in for week 1, I imagine.
Well, speaking about drive, do you want to take a question from in chat from Lancer RJH2 asking what drivetrain style is the Grasshoppers looking at using for this season?
Good question. We're actually going to mix it up a little bit this year. The last several years, 3 or 4, we've been using 2-speed transmissions with auto-shifting code, and that has been great for recent games. But this year, we're going to use a single-speed drive geared for 12.5, 13 feet per second, I think, with Coulson wheels. The 2 speeds are great. The various performance wheels and other high-end wheels that we've used are great, but they require a lot of maintenance. And we've decided we're going to avoid those maintenance challenges where we can. We know we're going to suffer a little bit of performance loss, but man, when you don't run out of wheel tread in the middle of district champs, it's that can be a worthy compromise. Right. In 2019, we came back from about halfway through our qual schedule, and there was 0 tread left on our wheels. So that was a tough.
Coulson might be a good pick then, since it's all tread, right?
Yeah, basically indestructible. We've run them in the past. We love them. You can drive 6-7 events on them before you wear them out if you're doing things right.
And are you doing like 6-wheel drive with a drop center on the Coulsons, or are you running them flat with an Omni, or
flat 6, or not quite a flat 6. We're doing a very gentle drop, maybe 60 or 80 thousandths, just enough to lighten up the front and rear axles a little bit and to reduce turning scrub a little bit, but not enough so that you can visibly see the robot rock. We found that when you run flat or with a very small drop, when defenders try to spin you, they can't, or it's really, really hard for them to spin you. And in a game where we're planning on shooting in an unprotected zone, that's a good feature to have.
Yeah. This game definitely has the potential for a lot of heavy defense, because the protected zones are kind of in a weird spot for that shot. It's not an easy shot where the protected zone is, and everywhere else is just like, all right, come hit me. Yeah, exactly.
Yeah, I expect to see a lot of how do I want to put this? There's going to be a lot of attempts made at defense, and I think with a smart offensive driver, they'll be able to run a pick using the field geometry around the hub to kind of scrape the defender off and go score in the next available launch pad area, if you will. And if you can park your robot and get your shots off before the defender can recover and come around the little wall there and hit you again, you'll be in good shape.
I want to move on a little. Oh, sorry, go ahead.
Sure. Yeah, go. No, that's fine.
No, that's fine. I want to just keep moving on. You have a couple cool things on your robot that you submitted or that you're looking at doing. First of all, I do want to bring up the phase 2 that you have on here, where you say 2 intakes ? And and talk about that a little bit. And then your team created a video showing some different testing with intake material. Can you talk a little bit more about that?
Yep. We'll start with the two intakes. If you can create a simple intake mechanism, it's often really easy to add a second one to the other end of your robot if your packaging permits. And then you have the option of collecting, say we drive up forwards. We're planning on having our collector on the back. So you drive up, you shoot, and you drive straight back to collect cargo without spinning or reorienting the robot. That takes a lot of time. They can add a second to a 2-second drive cycle, which is a really big deal when you're trying to do 9 or 10 a match. On the other hand, if we have the space and the packaging, we would like to add one on the front, so that if there is cargo in the way when you go up to shoot, say you only have one loaded in the robot and there's one of your cargo that you'd like to pick up in front of you, you can drive forward and scoop it up out of the way again without reorienting. And when you're planning on a 6-wheel drive and not a swerve, you want to avoid reorienting whenever you can. Was there? Yep. Perfect. Yep. So here we have unreinforced Velcro tape. We don't have our real game piece yet, but this is close enough. The Velcro does a great job of digging into it, but you can see it's already destroying it. This particular shot right here is rough top tread, which doesn't do the best job, but it could work in a pinch. I wouldn't recommend it. You can see it doesn't really control the, in this case, it's slightly overgrown tennis ball, not a completely overgrown tennis ball. It doesn't do a great job of controlling it. It just kind of bats it around, and maybe it kicks it up over the bumper, but generally not. Compliant wheels seem to do a good job, as they often do, but if you pay close attention, this fuzzy material is going to slip on a lot of bumpers, kind of in a big way. Like right here, you can see it did 2 or 3 revolutions before it climbed the bumper material and out. I think this is going to make over the bumper collection a little trickier than it was with power cells, which would just stick to bumpers. And the TIE Fighter wheels do a really good job of engaging it and just flipping the game piece over the bumper in a way that just friction doesn't quite do. So that's something else to think about, is maybe you don't want a perfectly round collector wheel. Maybe having cogs or recesses in it is going to get you a little more mechanical capture there.
Yep. So with your testing that you're doing here, obviously you're using a much smaller tennis ball. And I know that it's slipping on the bumper a little bit. What's the height that you think your team's bumpers are going to be at? Is it going to actually engage with the flat surface, or because it is? I mean, it's a 9.5-inch ball, right? So it's not
Yep.
It's a little bit different of a mechanic. But have you thought about your bumper height at all, or maybe even alternate materials for your bumpers?
So yes to both. Well, first in the video, we added 2x4s to get the center line of the ball close to where we think it'll be relative to the bumper, to try to account for that. A bigger ball will, of course, roll over that geometry more easily. We're planning on a 5-inch tall bumper as average, with a 6-inch height. I like having about an inch of ground clearance, and with the 3/4 to 7/8 elements we might find out on the field, that seems to be a safe place to be. So we'll be a little bit above. We'll be having contact on the vertical face of the bumper. Yep.
Cool.
And as far as alternate bumper materials go, we've only tested the ripstop nylon so far. If you're a team that leans towards the Cordura materials, they might do better. Velcro can be color matched to bumpers, and may be installed in key locations to give you a little more grip to roll the ball over.
That sounds like a Q&A question waiting to happen.
Yeah, that is going to be a Q&A question for sure. Historically, they've allowed Velcro on bumpers for double-sided bumpers. having, as long as it's color matched, it's fine. So that's something we're planning on asking, because we love our double-sided bumpers with Velcro. And if maybe that strip gets a little bit longer than it needs to be to help us with intake, well, we'll see. We're going to Q&A that one for sure.
Yeah, it's going to be fun. Hey, why don't you tell us a little bit about your climbing strategies for now?
Yeah. Tyler, you had one of the more interesting ones pulled up earlier.
You might have to elaborate a little bit more for me. Is it on shape or what?
On shape.
Yeah, in on shape.
Gotcha.
So we, one of our coaches is absurdly creative, and he came up with. He and I put this together. He's been doing most of it, to be perfectly honest. Where this sketch shows that you can climb up on the 6-point rail, 6-point bar, and then the 15-point bar is within the robot envelope at that point. So it is conceivable to build a mechanism that pulls you up at to the 6-point. You skip the monkey bar nonsense completely. You grab onto the 15, let go of the 6, and there you are. So that's what this sketch is showing. Right now, we're just working through the geometry of that particular approach. It's challenging, to say the least. You wind up, when you account for field tolerances, you wind up with very, very little material to actually connect with the 15-point bar. Manipulating your CG, if we choose to go this way, we will have to move our CG much further back to make it happen. This is the very simple sketch of what we're looking at for the phase 1, phase 2 portion of our build plan. This one is a dead center CG pull straight up on the 6-point bar. That puts the 10-point bar within the robot envelope, enabling the same type of handoff where you can grab the 10-point, let go of the 6-point, and you've got a 10-point hang relatively quickly. We believe that the 10-point climb can be a completely passive mechanism. That is to say, spring-loaded. Probably you release it, it extends out. You grab the 6-point, you climb up, you grab the latch onto the 10-point, let go of the 6-point, and swing down a little bit, and there you go. Hopefully.
Yeah.
Cross your fingers, right?
Yeah, that's interesting, because we talked with one of the other Open Alliance teams earlier, and they were talking about skipping the 10-point bar also. So it's interesting to see multiple Open Alliance teams kind of looking at those same pathways. That's kind of one of the benefits of the Open Alliance community too, is teams can have similar ideas during their brainstorm and kind of see how each other is viewing that.
That's been a huge benefit, both I think to teams outside the Open Alliance and certainly to those of us in the Open Alliance. Before, I think it was 2019, we published a gripper that we had been working on for the hatch panels, and Ty saw it, and less than 24 hours later sent a video of them using our gripper with an extra degree of freedom, an extra spring-loaded degree of freedom, and said, "Thanks for having an open build." Nice. Winky face. Like, oh God, that's so much better than what we came up with. And that's what we quickly modified our robot, built like 2 or 3 new parts, and sent them a video later that night of implementing their improvement on our robot.
I think that's a really cool thing about the openness of build, especially without bag, is that teams like yours that are planning to evolve throughout the season can definitely take things that they see at events, and if you're quick to be able to implement it, it's totally fair game, and I guess kind of encouraged from an inspiration perspective to be inspired by what else you see. So yeah, that's a great example of, like, you designed something and then someone else improved upon it, and then you got a better thing out of it. I mean, I think that's a really great way for the competition to evolve and go. It's very different than the days of old where everybody's hiding everything that they're possibly doing and keeping it to themselves. So
you get a week 6 teaser picture maybe, and those days were frustrating for me, frankly. I was like, I want to talk to some other teams. I want to see what they're doing. I want to get input, and it makes me so happy that the Open Alliance has turned into what it has.
Yeah.
Well, once again, if you're interested in learning more, of course, about what Team 95 is doing and the Open Alliance, check them out on Chief Delphi on their build blog, or of course in Discord as well. I do want to take one of the questions that we got, just actually asking about your video that you created. What camera are you shooting this in? This is a gorgeous shot that you have, by the way.
This is got the It's a high-speed camera, like a real high-speed camera. This is shot at 1,000 frames per second in 1080p. We bought this last year when basically all the events were canceled last year. We turned our travel budget into a high-speed camera for Open Alliance content. So we bought the whole shebang from Kronos. Waited like 6 months for it to arrive, but we got it in time for build. So here we are. Actually, I'd throw it out there to the larger audience. Especially once we get our real game pieces, if there is a high-speed video that you want to see, reach out to me on Discord or Chief Delphi, and we'll see if we can make it happen. We love doing this sort of stuff and we've got a coach and 2 or 3 students who love doing high-speed video content, so we're happy to create exactly what people are asking for.
Well, looking forward to seeing that and more coming from Team 95. Thanks again for coming on. Talk to us a little bit more. I know we'll have 95 on in just a few more weeks to see what your build progress is, and of course you can follow them, as mentioned, on Chief Delphi and on Discord. Thanks a lot, James.
Thank you. Have a good night, guys.
Thanks to Striker Careers for their support in this video. First alumni and mentors are making Striker a top priority for their internships and careers. That's because Striker knows that those in first are the leaders and innovators of tomorrow. If you want to help make the world a better place by creating life-saving medical devices and technology, get started at careers.stryker.com. Thanks to Kettering University for their support of this video. Over 1/3 of Kettering's current students are former robotics team members. Go pro at Kettering University and get a free t-shirt. Students in grades 8 through 12 and located in the continental US, scan the QR code and complete the form by January 31st, 2022 and receive more information about Kettering. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter. And First Updates Now on Facebook, Instagram, TikTok, and Twitter.